Okay, our next topic is the following. What is this thing? What we want to do, we want to find the points of intersection. We want to find the point of intersection of polar curves. We want to find the points of intersection of polar curves. How can we do this thing? Let us understand this thing with the help of the examples. We can consider the example which we have already above. So we consider this example. This was about finding the area, okay, or the area that lies inside the circle and outside the cardioid. And I will draw the figure one more time so that you can understand. Okay, so if you look at this figure, these two curves, they intersect at the points this theta equals to pi by 6 and theta equals to 5 pi by 6. Okay, so how can we find these points of intersection? How can we find the points of intersection? So in order to find the points of intersection, what you have to do, you have to put these two curves equal to each other. Okay, so what you need to do, you need to equate two curves. What does it mean? It means that you have to put, for example, 3 sine theta equals to 1 plus sine of theta. Bring this sine theta to the left hand side. It will become 2 sine theta equals to 1, and that will give you sine theta equals to half. Sine theta equals to half. So remember, if you remember from your previous knowledge from trigonometry, we remember this formula A, S, T and C. Remember, we have three trigonometric functions: sine, cosine and tan. So what does it mean? It means that in the first quadrant, this is our first quadrant, this one is the second quadrant, this is the third quadrant, this one is the fourth one. So the sign is positive in the first and the second quadrant. So suppose that if in the first quadrant the angle here it is theta, then in the second quadrant it will be equal to pi minus theta. So from here we get two values of theta. Theta equals to, and remember one more thing, sine pi by 6. Pi by 6 is 30 degree. We know that sine pi by 6 it is equal to 1 by 2. So from here we get two values of theta, pi by 6, and the second value will be equal to pi minus pi by 6. And from here theta equals to pi by 6 and 5 pi by 6. So these are the two lines, or these are the two intersection lines. Theta equals to pi by 6 and theta equals to here 5 pi by 6. That's how you can find the points of intersection of two polar curves. What you need to do, you have to equate the two polar curves and then find all the possible values of this. And then after finding these values, you can substitute this value of theta in the given polar curves, and also you can find r. Okay, our next example is the following. Find all points of intersection of the curves r equal to cosine 2 theta and r equals to 1 by 2. R equals to 2 cosine 2 theta. This is a four-leaved rose which we have discussed above. Mean it has four loops, and r equals to half. This is a circle. Okay, this is a circle. And we need to find their points of intersection. And we need to find their points of intersection. So if you look at this figure, how many points of intersection do we have? So in the first quadrant, there are 2 points of intersection. This 1 by 2, half, 3 by pi by 3, and the other one is half, pi by 6. The value of r will be fixed. Okay, the only thing that will vary is the angles. Okay, and then again we have 2 points in the second quadrant, again 2 points in the third quadrant. So in total there are 8 points of intersection. In total there are 8 points of intersection. So we need to find all of these points of intersection. Okay, so in total there are 8 points of intersection. So in total there are 8 points of intersection. So we need to find them. Okay, so we do the same thing as we have done previously. How do we start this thing? We will equate. What we are going to do, we are going to equate the two given polar curves, mean put them equal to each other. So what do we get here? We are going to get this thing, cosine of 2 theta equals to 1 by 2. Okay, so if you remember from your previous knowledge, we know that cosine of we know that, what do we know? We know that cosine 60, okay, cosine 60, that is cosine pi by 3, this is equal to 1 by 2. Cosine pi by 3, this is equal to 1 by 2. Cosine pi by 3, this is equal to 1 by 2. So it means that we are going to get two values of this thing. So what do we get from here? 2 theta equals to pi by 3. 2 theta equals to pi by 3, and that will give us theta equals pi by 6. Theta equals to pi by 6. So this is our the first angle. This is our the first angle. And what will be the second angle? Okay, the second angle will be equal to theta equals to pi by 3. How do we get the pi by 3? So these are the two angles in the first quadrant. Now again, remember from your previous knowledge that if we have an angle theta in the first quadrant, how do we find the angle in the second quadrant? It will be equal to pi minus theta. And how do we find the angle in the third quadrant? It will be equal to pi plus theta. And in the fourth quadrant, so this is the angle here, this is the angle to this one, and then to this thing, it will be equal to 2 pi minus theta, 2 pi minus theta. So in the second quadrant, so what will be our angles? So remember, in the first quadrant we have pi by in the first quadrant we have pi by 6 and pi by 3. So in the second quadrant it will be equal to pi minus pi by 6 and pi minus pi by 3. So pi minus pi by 6, it will become 5 pi by 6, and this becomes 2 pi by 3. What will be the angles in the third quadrant? In the third quadrant they will be pi plus pi by 6 and pi plus pi by 3. So pi plus pi by 6, that will give us 7 pi by 6, and this is 4 pi by 3. And in the fourth quadrant it will be equal to 2 pi minus pi by 6 and 2 pi minus pi by 3. This will give you 11 pi by 6, and that will give you 5 pi by 3. So these are the 8. So that's how you can find the 8 points of intersection of this thing. So first, what is the main idea? The main idea is, first we find the points of intersection in the first quadrant, and then we will find all the points of intersection in the other quadrants.